Okay, this is the last screencast, hopefully for your sake as well as mine, for today and maybe this weekend. So this is a review of Hess's law. I thought it would be a good idea to review it for enthalpy, heat of reaction, and then also for equilibrium. So I just put together a reaction here, and I gave it to you in several different steps with the heat of reaction. So remember, with Hess's law, what we're trying to do is manipulate the individual reactions so that the sum of the reactions equal my original reaction. So some of you are better at this than I am, and some of you struggle a little bit, so hopefully the struggle is almost over, which it is. So the first equation right here, what I'd like to look at is I like to look at the products first. So if I look at my product over here, I have HBr, so I search through my reactions, and there is the product. So because it's on the same side of the arrow, product, as it is in this reaction, I know I'm going to keep the sign the same. So somehow 200 kilojoules is going to work out for me. Okay, if I look at the reactants, I have an H. Here I have an H on the product side, so I know I'm going to have to reverse this, which means I reverse the sign. Same idea, I have a Br on this side, so I'm going to have to reverse that. The other thing is I have twice as many in all of my reactions as I do in my original equation. So I could wait to the very end and divide my delta H by 2, or I could individually do it. I'm going to wait till the very end. So again, my first reaction would be reversed. I'm just going to drop the gases because everything is a gas in this situation. My delta H is going to be negative. Remember, we just changed the sign. So I would definitely pause this and finish it up on your own and just check your answers with mine, if you haven't already done that. So then my delta H here would be a minus 10. And then my last equation, H2Br2 goes to 2HBr. And my heat of reaction for that one is 200 kilojoules. So I can see if everything adds up okay. So so here is my overall reaction, right? Way back up here. So if I add these three equations together, the H2 is on the product side, the H2 is on the reactant side, that goes away. My Br2 is on the product side, the Br2 is on the reactant side. So I'm going to add up the equations. I end up with 2H plus 2Br, all on the left side of the arrows, right? That's left, and then 2HBr. So when I added all the reactions, I would add all the enthalpies, and when I add that, I end up with 90 kilojoules. I don't know why I wrote K there. Okay, because I have a 2 in front of everything and my original reaction is only ones, I would divide this by 2. So my answer would be the delta H for the reaction is equal to 45 kilojoules. So hopefully you guys all remember that. Okay, next, Hess's law for equilibrium. So things change. We still need to make sure when we add up all the reactions, we end up with the same overall reaction. But when we're calculating the equilibrium constant, we don't add. Okay, and we don't change the sign to a negative because you'll never have a negative K. Okay, so looking here, the only thing I did is I just added a double arrow to indicate equilibrium, and I actually used real numbers. So the first reaction, again, we're going to reverse. So I'm going to save the divided by 2-ish thing for the end. So my first reaction, I'm going to reverse, and again, I'm just going to drop the gas here. And when you reverse an equilibrium constant, it's a 1 over. Which is the same as 11.8 to the minus 1. So it makes sense because if you remember, the equilibrium expression is the concentration of products divided by reactants. When you flip it, it's actually reactants divided by products. So we would do the same thing for the second one. And that would be 1 over 1.15 times 10 to the negative 5th. So I have this so far. That's not my answer yet. I have that so far. Okay, and then lastly, that's going to stay the same, right? So my Kc is going to be 2.78 times 10 to the negative 3. I'm sorry, positive 3. So again, when I add all those up, just like I did previously, I'm not going to rewrite everything. I'm going to end up with twice as many, right? So I'm going to end up with 2h plus 2br goes to 2hbr. Okay, so how do I calculate the overall equilibrium constant for the original reaction up here? So I don't add, I multiply. So what's going to happen is it's going to be 1.1 over 11.8 times 1 over 1.15 times 10 to the negative 5th times 2.78. Remember, I didn't have to do anything to the last equation, times 10 to the 3rd. Now, when I do that, it's going to give me double everything. But I don't want double everything. But I don't divide it by 2. What I do is I take the square root. And then your answer, I did have my answer somewhere. I think it's 4230 or something like that. So I think it's a right around 4230. I might have a number wrong there, but it's right around that. So just make sure you understand that. So when you are finding an equilibrium constant with a series of reactions, you multiply them all together. If it's reversed, it's inverse. If it's halved, it's raised to the square root, 1/2. If it's doubled, you square it. If it's tripled, you cube it, and so forth. Hopefully that helps.